Okay, we're going to continue talking about solving radical equations by looking at what we call extraneous solutions. So remember we talked about extraneous solutions before when we had like absolute value equations or inequalities. So this is basically a solution that isn't really a solution. So it's a solution we can discard, basically, right? So a solution that doesn't work. Okay, so how do you tell if you have an extraneous solution? Usually you can tell by checking. So this is where it's really, really important for you to check. So let's do a couple examples for you to see these extraneous solutions. So with example F, just like we did in class, what we want to do is get rid of that square root. So how am I going to do that? I'm going to go ahead and square both sides, just like normal. Alright, then that square cancels out the square root sign, so I get x squared equals 20 minus x. Great. Now I'm going to go ahead and solve this just like how I did last chapter, right? Anything I want. So I can try factoring, I can try completing the square, I can try the quadratic formula, whatever. I'm going to go ahead and make this in standard form. And like I told you guys last chapter, I like to try factoring when I can. So I'm going to go ahead and make my puzzle. And then see, this works out really nicely to be 5x and negative 4x. And then I can go and factor. Let me know if you have questions about factoring. I'm putting these dots in to represent my work because factoring is not the big concept today. It's the extraneous solution. So if you don't understand how I go from the puzzle to x minus 4 times x plus 5 equals 0, do let me know in class when we have time for questions. Okay? But from here, we get our zero product property, x minus 4 equals 0, x plus 5 equals 0, to get x equals 4 or x equals negative 5. Normally we'll see this and go, cool, okay, I've got two answers, let me box it. But here's where, ooh, geez, sorry about that, hold on. There we go, must have slipped my hand there. But here's where the check is super, super important, right? So if I'm going to check x plus 4, I'm going to say 4 equals the square root of 20 minus 4. Alright. So is 4 the square root of 16? Yes, looks great. Okay, what about negative 5? So I'm going to get negative 5 equals the square root of 20 minus negative 5. So negative 5 equals the square root of 25. That's actually not true. So I know when we did square roots before and we said, well, the square root of 25 could be 5 or negative 5. And that's true when we're solving for x. Okay? So this is a big, like, this doesn't work. Alright? This is not okay. Why is this not okay? Because this square root is a positive. Right? There's that invisible positive 1 in front, so we're saying the positive square root of 25 is negative 5, which is not true. So the only possible answer is x equals 4. Okay, so I want to make sure that's really clear. In this case, we're not solving, for example, let me show you the difference. So when we have x squared equals 25, and we square root both sides, then we're saying, well, what could x possibly be? So what number squared could be 25? That's where we do plus or minus 5. But when we're saying, you know, x equals the square root of 25, right, just like that, then we want to think, okay, well, this is a positive 1 times square root 25, so this is just 5. So it's a little different. It's kind of confusing, I can totally understand, but this is what we want to get used to here today. So let me erase that, and let's look at G. Okay? So again, if you look at this equation, think about this as 7 plus the positive square root of 3n equals 1. So just like we do before, we would isolate your radical sign, right? The square root of 3n equals negative 6, and let's go ahead and square both sides. And again, keeping in mind, this is a positive 1, right? So it's a positive 3n. So we want only the positive root. Alright, so I'm going to get 3n equals 36. Divide by 3, and n equals 12, right? And let's go ahead and check. 7 plus the square root of 12 times 3 equals 1. 7 plus the square root of 36 equals 1. Wait, no, something's wrong because the positive square root of 36 is 6, and 13 is definitely not equal to 1. So there is no solution here. So just a little tricky when we're looking at the radicals versus looking at quadratics. Okay? So think about what I was talking about with this no extraneous solution, or there's no solution. Go ahead and try 11 and 12. 11, 12, and 13 for me. Go ahead and try those out, please. Alright, let's go ahead and check. So hopefully for 11, you crossed off x equals negative 4. 12, you saw there was no solution. 13, if you got a little stuck here with this p plus 1 to the second power, remember, FOIL or do your box to get this p squared plus 2p plus 1. Alright, and the rest of it works just the same. Alright, and that is it for this section. So we're definitely going to be trying this out in class. Also, maybe moving on to the next section as well. So please, please, please come back with questions. I know extraneous solutions can definitely be a tough thing to understand. Alright, thanks for listening. So that is it for this section and radical equations. So please, please, please come back to class with questions. I know the idea of extraneous solutions, especially with the radicals, can be difficult, especially because we're no longer thinking about these square roots as plus or minus because they have that invisible positive 1, so we're only looking at those positive radicals. Okay? Thanks for listening.